All right, today's video is on simplifying radical expressions, which we did in the beginning of the year during first semester. So we're just going to review that. All right, so first off, we are going to simplify the square root of 30, or see if the square root of 30 is simplified. One way we could do this is we could break this up into all the factors. So 30 can be broken up into 3 times 10. 3 is prime, so we can't break it up anymore. And 10 we can break up into 2 and 5. All right, if we have any partners, that number can get pulled outside the radical. If we don't have any partners, they all get multiplied and go back inside the radical. So this is actually the square root of 30. Yes, the square root is simplified. All right, for part B, we have the square root of 28, so I can break that up into 4 times 7. Now, if you're going to break it up into prime factors, you could actually break it up into any numbers you want. So if there's other factors that go into 28, you could use 2 and 14, or any other factors that would actually work. All right, so 4 we could break up into 2 times 2, and then 7 is already prime. So anything that has a partner can come outside the radical. Anything that doesn't have a partner has to go back inside the radical. And then that would be my simplified radical. So no, this one was not simplified. All right, so that was one way we could do it, was to break up into prime factors. The other way we could do it is to use our perfect squares. All right. The square root of 64 is a perfect square. All right, remember you can use your calculator. We can hit second square root. Oops, go away. Square root of 8, square root of 64, which is 8. Okay, so always check to see if it's a perfect square first. All right, now 20 is not a perfect square, so you can go ahead and break that up into prime factors if you want, or you could find the biggest perfect square that goes into 20. So remember, we can use our calculators for this. We could put 20 divided by x into y1. We could put x squared into y2, and that will give me all the perfect squares. X squared. All right, and then we can go to our graph. All right, so starting at 1, all right, if we look in the y column, that will be the perfect square that shows up first. So 20 is not on our list, 10 is not on our list, and by list I mean the stuff that's in red. This is a decimal, it doesn't count. 5 is not on our list, but 4 is on our list. So 4 is the biggest perfect square that goes into 20. So we can break this up into the square root of 4 times the square root of 5, since 4 times 5 is 20. The square root of 4 is 2, and then we have the square root of 5. All right, I will show you for this one, if you wanted to break it up using the prime factors. You could use 4 and 5, you could use 10 and 2, then 10 we can break up into 2 and 5, and then 2 can't be broken up, and 5 can't be broken up anymore. All right, so we have a pair of 2s, so the 2 comes out. 5 doesn't have a partner, so it goes back inside. So we get the same answer no matter which way we do it. All right, 32. The biggest perfect square that goes into 32 is 16. 16 times 2 gives us 32. The square root of 16 is 4, and then we have the square root of 2. All right, 24, we can go ahead and break that up. The biggest perfect square that goes into 24 is 4. So the square root of 4 times square root of 6. The square root of 4 is 2, and then we have the square root of 6. All right, go ahead and pause the video and try these 2 problems, and then come back and check your work. All right, for 19, you should have gotten the square root of 9 times the square root of 2. The square root of 9 is 3, and then we just keep the square root of 2. The biggest perfect square that goes into 72 is 36. So we have the square root of 36 times the square root of 2. So that gives us 6 square root of 2. All right, next up, just remember anytime you multiply a number inside the radical times itself, that number comes outside the radical. So remember, the square root of 6 times the square root of 6 is the square root of 36. 36 is a perfect square, so you get 6. All right, when we're multiplying, you're going to multiply the two numbers outside the radical together, and then you're going to multiply the two numbers inside the radical together. And then we would go ahead and simplify the square root of 80. All right, so the biggest perfect square that goes into 80 is 16. So 16 times 5 gives me 80, so I keep both those numbers in the square root. Okay, the square root of 16 is 4. And then finally we can multiply the outside numbers together. 12 times 4 gives us 48, square root 5. All right, go ahead and pause the video, try part C, and then come back and check your work. Okay, so you should have gotten negative 4 times 2 is negative 8. 6 times 3 is 18. We can simplify the the square root of 18 by the square root of 9 times the square root of 2. Okay, the square root of 9 is 3, and then we keep the square root of 2. So we end up with negative 24 square root 2. All right, the new part here is dividing radicals. That's what we're going to be using with our trig. All right, so in order to get rid of a fraction inside a radical, we can go ahead and break it up into two separate fractions and then simplify the radicals that way. All right, so I can break this up into the square root of 13 all over the square root of 100. 13 is a prime number, so we can't simplify that, so we're just going to leave that with the square root of 13 on the top. And then the square root of 100 is 10. We cannot simplify inside numbers with outside numbers, so we're going to leave it like that. All right, now part B, we have the square root of 8 divided by the square root of 3. All right, it's already broken up for us. Now, we cannot simplify the square root of 3, but we also can't leave a radical in the denominator. So in order to simplify this or get the radical out of the denominator, I'm going to multiply by the square root of 3 to the denominator. Now, if I multiply by the square root of 3 to the bottom, I also have to multiply the same exact thing to the top. All right, so in the numerator, these are both inside the radicals, so I'm going to leave that as the square root of 24. And then on the bottom, we get the square root of 3 times square root of 3, which we talked about up above. Anything times itself in the radical just comes outside the radical. So that's why we multiplied by the square root of 3, because now we don't have a radical in the denominator. Okay, we can't simplify the 24 and 3 because one's inside, one's outside. But we can simplify the square root of 24. All right, and I believe we did that in the last page. But the biggest perfect square that goes into 24 is 4. So 4 times 6 is 24. The square root of 4 is 2, and then we have the square root of 6. So instead of the square root of 24, I'm going to write 2 square root 6. And that's my new numerator, and then I get 3 in the denominator. Now I cannot simplify the 6 and the 3 because one's inside the radical, one's outside the radical. So the only thing I would be able to simplify is the 2 and the 3, but 2 and 3 do not simplify as a fraction. So we would just leave that as our solution. All right, last page here, a couple more examples. All right, we have 5 divided by the square root of 7. We cannot leave the square root of 7 in the denominator, so we're going to multiply the top and bottom by the square root of 7. Now on the top, I cannot multiply those numbers together because one's inside the radical and one's outside the radical. So I'm just going to rewrite it as 5 square root 7. Now on the bottom, I have the square root of 7 times the square root of 7, which is just 7. Okay, I cannot simplify the 7s because one's inside, one's outside. 5 and 7 do not simplify, so that is my answer. Okay, why don't you go ahead and pause the video, try part B, and then come back and check your work. All right, so you should have multiplied the square root of 3 to the top and bottom. On the top, we get the square root of 6. On the bottom, we get 3. We cannot simplify that, so that is my final answer. All right, go ahead and try number 1 and then come back and check your work. Okay, we should have multiplied the top and bottom by the square root of 6. On the top, we get 3 square root 6. On the bottom, we get 6. Now, in this case, we can simplify 3 and 6 because they're both outside. So 3 divided by 6 turns into 1/2. So we end up with the square root of 6 on top and 2 on the bottom. We cannot simplify those because one's inside the radical and one's outside the radical. All right, number 2, there's a couple different ways you could do this. You could go ahead and simplify right away, or you can divide right away because those are both inside the radical. So you could take 64 and divide it by 4, and you would get the square root of 16, and then you could simplify the square root of 16, which is just 4. Okay, if you wanted to break it up into 2 different radicals, the square root of 64 is 8, the square root of 4 is 2. 8 and 2 are both outside the radical, so we can simplify those and we get 4. So you get the same answer no matter which way you do it. All right, now we have a 6 on the outside. We have a 12 and an 18 on the inside. I'm going to go ahead and simplify these because they're both inside the radical. So let's see, I can take a 6. So 6 goes into 12 2 times, 6 goes into 18 3 times. So now I have 6 times the square root of 2 divided by the square root of 3. We cannot leave the square root of 3 in the denominator, so I need to multiply top and bottom by the square root of 3. On the top, I need to rewrite my 6, and then I can multiply the 2 and 3 together because they are inside the radical. And then on the bottom, I get 3. Now, these two numbers are outside the radical, so I could take 6 and 3 and divide them, and I get 2 over 1. So in the numerator, I get 2 square root 6, and then denominator is just 1, so you don't have to write that. All right, number 6 here. Now you could go ahead and you could simplify first, or you can get rid of the radical in the denominator. I think it's easier to simplify first, so I'm going to do that. So 2 and 4 simplifies to 1/2, and 3 and 6 simplifies to 1/2. All right, now in the numerator I have a 1, and then I have the square root of 1, which is just 1. So I get 1 in the numerator. On the bottom I have a 2 outside the radical, and then a 2 inside the radical. Now I can go ahead and simplify this. I have to get rid of the radical in the denominator. So I'm going to multiply the square root of 2 times the top and bottom. On the top I just get the square root of 2. On the bottom, I have this 2 that was outside already, and then the square root of 2 times the square root of 2, which is 2. So I have the square root of 2 on top, 4 on the bottom. I cannot simplify those because one's inside the radical, one's outside the radical. All right, number 7, 15 and 3 are both inside the radical, so I can write them together and then simplify. 15 divided by 3 gives me 5, and I'm going to keep that inside the radical. Since it's in the numerator, I don't have to do anything with it. All right, and then number 9, I have 12 divided by the square root of 4. The square root of 4 is 2. 12 divided by 2 is 6.